Good afternoon, my 2315 students. Yesterday was a final day of our class for the fall 2023 semester. And unfortunately, we were unable to complete the chapters that we needed to because we ran out of time. I was about to complete chapter 14. I think it was only remaining a slide or two. And then we were supposed to also begin on chapter 15, which is a very short chapter. I just want to show you guys a few stuff there. So I'm going to be recording this lecture, and I'll post the recording at Canvas. Make sure you watch the video before your final exam next week, because if you don't, part of this material is going to be on that final exam. You may have problems. It should not take us too long. Okay, so I'm going to share my screen, chapter 14 where we stop. So we complete that chapter, then I'm going to do 15 quickly so that you guys get caught up on what I wanted to complete last time. So let me share my screen and we begin from there. Okay, so we left yesterday when we were discussing the tools of monetary policy, the tools that the Federal Reserve uses to control the supply of reserves in the banking system, controlling the size of monetary base and controlling the size of deposits and money supply overall. Because when the Federal Reserve changes policy, they tend to influence money supply, the total stock of dollars that exists in the economy, and interest rates. So there are basically 6 important tools of the Federal Reserve monetary policy, the tools that the Fed is going to use to control the supply of dollars, monetary base, and reserves in the banking system. The first 3 tools are the most important ones, which the Fed has always used ever since the Federal Reserve was created in 1913 through an act of Congress. Then the last 3 are like interest rate on reserves, overnight reverse repurchase agreement facility, term deposit facility. These are kind of like newer tools that the Fed has recently started to control money supply. So the most important tool of monetary policy, actually among the 6, the one that the Fed uses, say about 96% of the time when the Fed wants to fix the economy, is the first one, which is the open market operations. And I talked about it yesterday. So what is open market operations? So open market operation, as I said yesterday, is basically the buying and selling of treasury securities or treasury bonds by the Federal Reserve in order to control the money supply in the economy. So to increase the money supply, the Federal Reserve is going to direct its trading desk in the New York Federal Reserve District to conduct an open market purchase of U.S. Treasury bonds, typically from banks. These bonds are always like short-term bonds, which are like 1 year or less to maturity, sometimes medium-term, 2 to 10 years, or long-term sometimes. So to decrease the money supply, we said yesterday that the Federal Reserve is going to sell its securities. Then that's what we call an open market sale. Okay, so the Fed wants to increase the money, so decrease the money supply, they sell treasury securities to private banks. Sometimes they could sell it to the non-bank public, like to us, the members of the public, or to corporations. But we saw yesterday that when the Fed sells treasury bonds to banks, for example, this time around, the banks are the ones supposed to be buying something from the Fed. So traditionally, when you buy something from someone, you need to write them a check, or you either pay for it using money. In this case, the banks who are buying treasury securities from the Fed do not have to write a check or pay for it using currency. Why? Because the banks already have an account with the Federal Reserve, which is called the reserve account. So when the Fed sells something to banks, instead of the banks paying the Fed for that purchase, the Federal Reserve is going to debit the bank's reserve account, the bank's accounts with the Fed, by the actual amount of the sale, and the transaction is complete. To increase the money supply, as we saw yesterday, the Federal Reserve does the opposite. They are going to buy or purchase treasury securities or treasury bonds. We call that an open market purchase from banks. So, and again, because the Fed would be the one buying these treasury securities, traditionally, when you buy something, you write a check to someone who's selling those stuff to you, or you pay for it using currency, money. In this case, the Federal Reserve does not need to write a check to the banks when it buys securities from banks. All the Fed needs to do is just credit the bank's reserve account, bank's account with the Fed, by the same amount of the purchase, and the transaction is complete. But once the Fed does that, banks now have more reserves, which they can lend out to the public, okay? So, and we're assuming that one of the assumptions for this model is that banks keep no excess reserves. So when the Fed buys $10 million worth of treasury bonds from banks, the banks are going to start lending all those excess reserves, and that is going to trigger multiple lending in the economy. So at the end of the day, deposits in the banking system as a whole is going to increase by more than the size of that bond purchase. And then money supply is also going to increase because of the money multiplier process, okay? So let's first see one example here. So let's say, and what I gotta warn you, my writing on this computer screen using a digital pen is not pretty. It's gonna look like chicken legs. I hope you'll bear with me to see what because as I talk and you're watching the video, you hear my words, and you hopefully you don't get confused with what I'm writing on the screen. So let's do an example here. Let's say I'm gonna open allow me to open a new slide here. So let's do an example here. Let's say, suppose, kind of like some similar to example we did yesterday, but I want to do with a different size of the reserve requirement ratio. So I'm going to write here, say, example on the open market purchase. We're going to say, suppose the Federal Reserve, which we normally abbreviate as a Fed, buys $10 million of Treasury securities from banks. In this case, the banks are the ones selling. Okay, so the question could come that show the effect of this bond purchase, the effect of this bond purchase on the balance sheet of the Fed and those of banks, and those of the banks. So that means we're going to demonstrate, we will show, because once you buy something, a bond is an asset, treasury bond is an asset. You buy something, you gain it. That means your assets go up in size. So the Fed is the one buying. That means the assets of the Fed, treasury securities, are going to increase. But for the banks, they will see that the size of their assets, treasury securities, is going down because they sold them to the Fed. But because a balance sheet is a double accounting entry, you're going to soon learn that even though the banks have lost their treasury securities sold to the Fed, they're going to gain an equal amount of reserves. The Fed is going to credit their reserve account, because that's how the Fed is going to pay for those securities. Okay, so that's question number one. Question number two that we need to answer here is we're going to look at how this bond purchase is going to affect the size of reserves in the banking system. So Roman, I call this Roman 2. I'm going to say, what is the impact of this 10 million bond purchase, of this bond purchase on the reserves and the monetary base. Remember, the monetary base is a liability side of the Fed's balance sheet. It's the sum of currency plus reserves. So monetary base, we want to see how that changed. And then Roman 3, suppose the reserve ratio, the required reserve ratio, which is always set by the Fed as a regulatory requirement, is say 20%. What would be the change in the money supply in the deposit in the banking system as a whole, and money supply. So we want to see how that bond purchase is going to affect the supply of dollars in the economy. Okay. So and again, you want to excuse my handwriting on the computer screen. Not easy. It's not easy writing. It looks like chicken leg, but I hope you guys can bear with me. So let's knock out question part Roman 1. So this is Roman 1, how we answer the open market operation, which is buying. Okay. So we want to see how the balance sheet of the Federal Reserve is going to change. We did this yesterday, but with a different. So anyway, so we have seen that the Fed has purchased $10 million worth of treasury bonds from banks. Okay, that means the banks in America, the banking systems, are ones selling their treasury securities to the Fed. And when you sell something, you lose it. So now when you use a simple T account, which is a bank balance sheet, the balance sheet on top is for banks. The one at the bottom is for the Federal Reserve. We want to see how that bond purchased by the Fed affects the balance sheets of the banks and those of the Federal Reserve. So for the upper panel, you can see that because the banks have sold their treasury bills. Treasury bills is another way of saying treasury bond. These are bonds that mature within 91 days. So we call them treasury bills. So banks sold their securities to the Fed because the Fed was the one buying. So you can see that when you sell something, you lose it. So treasury bills of banks or their assets are going to go down by $10 million. That's why we put negative $10 million there. See, I take this negative $10 million. And then, but remember, when the Fed buys this thing from the banks have sold their security to the Fed. As I said before, when you sell something, you're supposed to pay for it either using cash or carry check. In this case, the Fed doesn't need to carry check to banks. The Fed is going to credit the bank's reserve account by the actual amount of the purchase. Reserves are bank deposit with the Fed. That's why you see that the bank reserves are going to go up by $10 million. So in a normal, because a balance sheet, since a balance sheet is a double counting entry where transaction enters a debit and a credit. On the one hand, we have debited the bank's treasury bill account, but we have credited in them with with $10 million of reserves. So if the balance sheet of the banking system were balancing before, it better still balance. Why? Because we have subtracted $10 million on the asset side and added $10 million. So there will be no change in terms of like assets being more than the liability side. The balance sheet will still balance. Meanwhile, on the balance sheet of the Federal Reserve, remember, because the Fed is the one buying treasury bills or treasury bonds from banks, you can see that the assets of the Fed, when you buy something, you gain it. So the assets of the Fed is going to go up, $10 million. There are more treasury bonds, treasury bills around. But the Fed has credited the bank's reserves with $10 million. While reserves are banks' assets, they actually show up as the Federal Reserve liabilities. That's why on the liability side of the Federal Reserve balance sheet, the reserves have gone up $10 million. So that's the impact on the balance sheet that I wanted to show. Okay, so now the second question says, what will be the effect on reserves and the monetary base? So that is actually straightforward. You can see for it clearly that if you look at both the balance sheet of the Federal Reserve that we have just demonstrated up there, both the reserves are going to go up by $10 million. So Roman 2, change in reserves. Okay, when I say delta is a Greek letter of the alphabet. Delta always we use it to represent change. So the delta R means change in reserves. Remember, R is your notation for reserves. So reserves are going to change by what? By $10 million. We saw that already on the balance sheet of the Fed and of the balance of those of banks. And now we also learned from yesterday that the monetary base is a sum of currency plus reserves. It's essentially the liability side of the Federal Reserve balance sheet. So if you take the change, both sides, you take change of monetary base can be brought about because of change in currency or plus change in reserves. We know that the currency component we have not been told is going to change. The only thing that has changed on the right-hand side is reserves. The reserves has gone up by $10 million. We just demonstrated that. So therefore, that means the change in the monetary base here is going to go up by what? By $10 million. And that's it. Okay, let me caution you. If the Federal Reserve had purchase these treasury bonds from the non-bank public, let's say from us, because we, the non-bank public, we, the public, or corporations, we don't have an account with the Fed. So if the Fed were to buy treasury securities or treasury bills from we, the members of the public, the Fed would have to pay for that security using a check, or they should pay for it using currency, cash. So if let's say they had purchased this from the non-bank public, from we, the members of the public, then currency in circulation would be the one that is changing. The change in reserve would be zero. So, but overall, monetary base will still go up by $10 million. But only the composition of that monetary base, the currency is the one that would change rather than the reserve. So that's the way it is. Now, to establish how this transaction is going to affect the money supply, it's going to affect the size of the money supply and the size of deposit in the banking system. So we already talked about it. Once after the Fed has increased reserves in the banking system, that money comes in the form of excess reserves, meaning that, let's say it was Bank of America that the Fed purchased $10 million of bonds from. That means Bank of America now has excess reserves of $10 million because the Fed has credited their account by $10 million. And because our assumption says that since banks must keep no excess reserves, that is going to start triggering multiple lending in the economy. So Bank of America is going to lend that $10 million maybe to some corporation. And then the corporation that receives that $10 million, they're also going to deposit that $10 million of new loan into their account, let's say with Citibank. And then from that point onwards, any new lending by from Citibank, they must keep at least 20%, as we have said, as required reserves. So Citi is going to loan up to 80% of that $10 million. But 20% of that, which is $2 million, must then be deposited with the Fed. That's what we call the required reserves, because 20% of 10 million is 2 million. So 8 million will be what Citi will lend out. And then whoever picked the $8 million loan from Citi might have an account with Wells Fargo. Wells Fargo, they're going to deposit the $8 million into the account with Wells Fargo. And then again, by law, Wells Fargo is going to keep 20% of the $8 million. 20% of $8 million is like $1.6 million. Then the remaining balance, they are going to lend out to some other individuals or company. So that is going to trigger multiple deposit creation in the banking system. So at the end of the day, once all those lending is complete, deposit is going to increase by more than $10 million. And we already talked about this in our previous lecture. So how do we know how the deposit is going to change? So Roman 3, we have been asked to show how the deposit is going to change. So the change in the deposit, delta D, you take initial deposit, and then you multiply that by 1 over the required reserve ratio. Okay, so the idea is that when the bank that first received the $10 million whatever increase in reserves, when the Fed purchase bonds, they are going to lend that $10 million out, and that $10 million is going to be deposited into somebody's bank account. So that in the initial deposit actually is going to be the same as the size of the initial bond purchase, which is a $10 million. So if we put $10 million here as initial deposit, we're going to multiply this by 1 over the reserve requirement ratio, which we have been given in the problem as 20%. 20% is the same thing as 0.2. So that means the change in deposit in the banking system as a whole is going to increase to what? It's going to increase to $10 million times 1 over 0.2 is 5. So that 5 times 10, so deposit in the banking system as a whole eventually is going to increase to $50 million. 5 times as much, okay? And then also recall, how do we show how the money supply will change? Remember, the money supply, which is our narrowest definition of money, when we talked about how we measure money supply, we're going to use the narrowest definition. So M1 is the sum of currency in circulation. I'm going to say C represents currency plus size of deposit in the banking system, then size of savings, this checkable deposit, which is like checking accounts, and savings deposits. So we can also look at how the money supply would change. Delta M1 would change because we have changed currency, plus maybe we change deposit, plus we change savings. But the source of change here is coming through deposit. So it's the deposit that is changing by $50 million. we would assume that the change in savings is zero and the change in currency is zero. So in this case, the money supply also is going to increase by $50 million. So that is how the Federal Reserve can change the size of money supply in an economy using its bond purchase policy, or what we call open market operations. Okay, so here I've shown you one side of the equation. If the Fed wants to increase the money supply, they purchase bonds from banks. What about if the Federal Reserve wanted to decrease the money supply? What would they do specifically? Okay, so let's look at that as well. Okay, so suppose the question had been posed to you that so we know that to decrease the money supply, the Fed would sell bonds instead of buying. Okay, so we know that to decrease the money supply, the Federal Reserve, which we normally abbreviate as the Fed, sells bonds instead, sells bonds, or conduct what we call an open market sale, bonds to banks. Okay, so let's say suppose the Fed conducts an open market sale, of treasury bonds in the tune of $10 million to banks. So then again, now I don't want to repeat the writing that question that I already posed before. Now here we want to see if the Fed is selling bonds to banks instead of buying, how will that affect the balance sheet of the banks? And how would that affect this type of transaction affect the balance sheet of the Fed itself? And then afterwards, we're going to show how the Fed would change the size of reserves in the banking system and change the size of monetary base, size of deposit, size of the money supply. So let's go do it. So since you already know what we've been doing here, first thing we want to show how the balance sheet would change. Balance sheet of both, because there are two parties involved in these transactions, the banks and the Federal Reserve. Okay, so let's look at the balance sheets, how balance sheets would change. So let's start with the one for the Federal Reserve. So when the Fed sells, so this is for the T account, or the simple balance sheet of the Federal Reserve. So we want to see just what changes in the Federal Reserve's balance sheet. So on the right-hand side of this T account, remember we record again liabilities of the Fed. Then on the left-hand side of the T account, we record assets. But you guys know how to do the balance sheet, so this shouldn't be a problem. So we're saying that the Fed is conducting a $10 million bond sale to banks. When you sell something, you lose it. So that means the assets of the Fed, what we're calling treasury bonds or treasury securities or treasury bills, is going to go down by by $10 million. If it goes down, so that means you need to put negative $10 million, meaning that the Fed has lost $10 million of its treasury securities because they sold them to the banks. But remember, the banks are the ones buying this time. When you buy something from someone, you either write them a check or you pay for it in cash. And that's normal transaction, you guys know that. But the banks don't need to do that, as I said before. Banks already have their account with the Fed called a reserve account. So let me draw the balance sheet of banks, all banks in America who are purchasing these treasury bonds from the Fed. So we can call this the banking industry, because several banks might be involved in it is not only one bank. Maybe Bank of America might be buying some, Citi might be buying some. We just call it a banking systems balance sheet for all banks who are engaged in this transaction with the Fed. So overall, we're going to say that because the banks are the ones buying this time, they're buying treasury bills or treasury bonds. That means the assets of the bank. So remember, this is assets on this side. This is liabilities on this right-hand side of the balance sheet. So since the bank's assets, treasury bills are going to go up because they're buying. So that means we're going to add $10 million here. Okay. But remember, the banks have an account with the Federal Reserve. So if they buy something and that increases the assets by $10 million, how are they paying for it? They're paying for it using their what? Their reserve account. So the Fed is just going to debit the bank reserve account by the actual amount of the sale. So that means bank reserves are going to go down $10 million. So while reserves are the bank's assets, they're actually the Federal Reserve's liabilities. So on the right-hand side, on the Federal border, we record what? Reserves. So that's the same reserves, which is going to go down what? $10 million. So the monetary liabilities of the Fed component, which is reserves, is going to go down $10 million. So if the balance sheet of the Federal Reserve was balancing before this transaction had happened, because a balance sheet is a double accounting entry, transaction end as a debit and as a credit. If you subtract $10 million on the asset side and turn around and subtract $10 million from the liability side, the balance sheet will still stay the same. If it was balancing, it will still balance. The same here for banks. Nothing has happened on the liability side, but we have added $10 million on the asset side and turn around and subtract something worth $10 million. So if the balance sheet of the banks were balancing before, they will still balance. There's no question about that. Okay. So that's how we illustrate this. But now the question is, how would this transaction affect the size of reserves? So that is straight. You know that reserves has changed. So and you just look at the balance sheet. The reserve is negative $10 million. So that means reserves has gone down by $10 million, because one of the questions would ask you like that, right? So we know that the change in reserves is going to be $10 million negative. Reserve has gone down $10 million. But then what about monetary base? You know the formula. Monetary base is a sum of currency plus reserves. So if you express this in terms of change in the monetary base is going to be equals to change in currency plus change in reserves. So in this example, we're assuming that the currency component has not changed. If the Fed was selling these treasury bonds to the non-bank public, then yes, the non-bank public, we would be buying it from the Fed, we would be paying for it using cash. But the Fed, in this case, is dealing with banks. So there's a reserve that is changing by what? By $10 million, going down $10 million. So that means the monetary base is going to go down by what? $10 million. So what have we learned so far? We have learned so far that if the Federal Reserve buys bonds, like the first case that we saw right here, bank reserves always go up by the same amount of the bond purchase. If they're purchasing this from banks, and then the monetary base also increases by the same amount of the what? Amount of the bond purchase. And the converse is true for a bond what? For a bond sale. If the Fed is selling bonds, the reserves in the banking system as a whole is going to go down by the what? The same size of the bond sale by the Fed. And the monetary base or the monetary liabilities of the Fed will also go down by the same amount of the bond what? The bond sale by the Fed. Or the okay. So, but what is the eventual impact on the deposit in case of a sale like this, an open market sale like this? So we already established that. So the signs are the ones that are changing indeed. So here, what we're gonna do is that we know that in this example, we're assuming that the required reserve ratio is still 20%. 20% is the same thing as 0.2. So we know that from our formula, change in deposit is going to be equals to initial deposit or initial bond. You can just call it initial deposit or initial bond sale. Initial bond sale times what? 1 over the required reserve ratio. So it's a bond sale or deposit, initial deposit. So this is a case where the Fed is actually debiting the bank's reserve account. So that means the banks are losing reserves. So essentially, that $10 million that they should have lent out to other people is no longer there because the Fed has decreased it. They have debited that account when they sold the securities of Fed. So all you will do, you're just going to put the sign here, negative what? Negative $10 million, because banks have lost that. Then you multiply this by 1 over 0.2. Okay? Which is going to be the same thing as negative $10 million times 5. So this is 50 million. So that means the change in deposits in the banking system is going to go up what? 5 times as much, $50 million, 5 times as much as the initial bond sale. What about money supply? And again, we know that money supply is a sum of currency in circulation, deposit, and savings. That's how we define M1, which is the narrowest definition of money, or the narrowest measurement of money in the economy. So we know that money supply, M1, is a sum of currency plus deposit, then plus money in the savings account. Deposit means that's checkable deposit, money in the checking account. So if we take the change, so the change in the money supply is going to be equal to change in currency plus change in deposit plus change in what? Savings. But we're assuming that the change in saving is not changing. The only thing that has changed is deposit, which has decreased by what? $50 million. So therefore, the change in the money supply from that $10 million bond sale by the Fed, that's going to decrease the money supply overall by $50 million. Okay. And again, now you can try several examples. I'm going to write, you have a homework which is due this Friday, I believe Friday or Saturday. I'm going to assign the last assignment for chapter 15 when I start. So you should be able to find some good examples there to practice in that homework assignment. Okay, so that's seems to be the most important tool. So the second tool that the Fed can use to influence the size of reserves in the banking system, the Fed can use what we call the discount policy. So this is how it works. The Federal Reserve is a banker's bank, is a lender of the last resort. So when the Fed lends money to banks, bank reserves are also going to change. You know what I mean? It affects the reserves in the banking system. Because let's say Bank of America borrows $10 million from the Fed. Okay? When you borrow money, even when you borrow money from your bank, you don't go with a bag and load the money in the bag and bring it back home. No, that's not how it works. All you got to do is just instruct your bank to do what? To put the loan that you've been approved for into your account with them. If you don't have an account with that bank that approved you for a loan, all you got to do is just give that bank, the routing number and your account number with your bank. And then the bank that approved you for a loan will wire that money into your account with your other bank. The transaction is going to be complete like that. That's the same thing here. When the Fed is going to loan the money to banks, the Fed does not need to, the banks do not need to carry cash to the bank. They're just going to credit their reserve account, the bank's account with the Fed. And that's that transaction. It's like basically creating accounts here. So let's talk about it. We talked about it already the other day. The discount rate is the interest rate that's paid on money banks borrow from the Fed. There's no free lunch. If Bank of America borrows $10 million from the Federal Reserve, the Fed might charge them 10% on that loan. It's only typically an overnight lending, 2 weeks, 1 month, short window. They loan money within a very short period of time. Okay, so let's talk about how that discount lending is similar to the buying, how it affects reserves. So let's say, let me do an example here. I think I did one in class already. So suppose, okay, so let's say suppose the Fed loans $10 million, or give a discount loan of $10 million to the banking industry. So if that is happening, so we want to see how the balance sheet of the Fed is going to change and how the balance sheet of the banking industry is going to change. Banking industry. Again, on the liabilities, on the right-hand side of a T account, we represent liabilities, you know that. And then on the left-hand side, we represent assets. For the Fed is the same thing. Liabilities go on the right. And then assets go on the what? On the left. So a loan is an asset of the Federal Reserve. It's an investment. When the Fed loans money to financial institutions like to the banking industry, the assets of the Fed, we're going to say loans to banks. That means that's an asset, which is $10 million. So the assets, $10 million has increased, and then the banks, that is going to show up as a liability. So that liability is going to be what we call borrowing from the Fed, which is supposed to be positive $10 million. That's a new debt. Debt always go on the liability side. Okay, so while loans to financial institutions, to banks, count as the assets of the Fed, they count as a liability that wherever bank is borrowing those funds from. Okay, the bank is whoever that bank which is borrowing money. Okay, but a balance sheet is a double accounting entry. So what happens here is that when the Fed, as I said before, when the Fed lends $10 million to banks don't need to go to the Fed and carry that cash, in a truck. They already have an account with the Federal Reserve called the reserve account. Reserves are the bank assets. What the Fed has done here is that the Fed is just going to credit the banking industry's account with the size of the loan. We're gonna credit the bank reserve account by $10 million. And you know that while reserves are bank assets, that the Federal Reserve liability. So reserves on the right hand side of the Feds is going to be $10 million. Change 10 plus. So that's how the balance sheet would change. So which is similar. So it would increase reserves the same way as the Fed would like buy bonds. So here reserves also going to go up by 10 million, and then the banks whose reserves have gone up 10 million who have got this loan from the Fed, they're going to start extending those loans to us, the non-bank public. Because the Fed has given them $10 million. What do they do with the $10 million? They're going to start loaning out to the non-bank public, to us, and that is going to increase money supply. The same way that when they buy bonds. And that's going to be the same way. So reserves going to go up $10 million. Monetary base is going to go up $10 million. And if the reserve ratio is still 20%, that means both deposits and money supply are going to change by $50 million. So the same way. So let's discuss this policy a little bit more, because that's the second policy that the Federal Reserve uses to control the supply of dollars in the economy. We call it a discount window policy. So as I say, the question is, how does the Fed increase the money supply using this policy? How does the Fed induce banks to borrow from the Fed? So if the Fed wants to increase the money supply in the economy, they're going to make it easier for banks to borrow money from the Fed. And how do they make it easier for banks to borrow money from the Fed? They are going to lower the discount rate. The discount rate is the interest rate that banks are going to pay for any loans they borrow from the Fed. Because if they lower the discount rate, that induces banks to start borrowing from the Fed. That means it's cheaper to borrow from the Fed. So when the idea is that when the Fed lowers the discount rate, the interest rate it charges banks when they borrow from the Federal Reserve, banks would borrow more funds from the Fed, and then they're going to lend those funds to the non-bank public, then money supply is going to grow. If the Federal Reserve wants to tighten policy, they want to reduce money supply, they're going to do the opposite. They're going to raise interest rate, the discount rate. So when they raise the discount rate, they're making it difficult for banks to borrow money from the Federal Reserve. Okay, then that is going. So when banks cannot borrow from the Fed because it's expensive, that is going to affect money supply negatively. Money supply is going to go down, and the deposit in the banking system is going to go down because if banks have not borrowed funds from the Fed because of high discount rates. So that's how it works. So you would argue that when the discount rate is high, that is going to reduce money supply, because banks are going to find it difficult to borrow from the Fed at high discount rate, high interest rates. But when the Fed lowers the discount rate, they're making it easier for banks to access the discount loans from the Fed. So then they will be able to extend those same loans to us, a non-bank public. The money supply will grow in that case, and deposit will grow as well. Okay, so the third, we already discussed this, is the reserve requirement ratio. So the Federal Reserve sets the required reserves for all banks. Okay, how do they do that? Let's see how. One more slide here. So you already know. I already told you guys. And I told you at the beginning that those are the three key monetary policy tools: open market operations, buying and selling of treasury bonds, the discount window policy or the discount rate policy by the Fed, and then the third one is the reserve requirement ratio. The Fed sets the what? The Fed is the one that sets the required reserve ratio. So for example, so that RR we talked about, which is 20%. If they say that 20%, okay, so the Fed might say, okay, if we lower the Fed might lower the required reserve ratio. Okay, so if the Fed lowers the required reserve ratio, say to 10%, what does that mean? From 20% to 10%. That basically means that the Fed is telling banks that, because remember, required reserve ratio is the percentage of customers' deposit that the banks must not loan out. In fact, that money must be deposited with the Fed. And the Federal Reserve audits all banks in America every 2 weeks to ensure that the banks are keeping up with the minimum reserve requirement ratio. And it's an easy audit because all banks already have an account with the Fed. So for Bank of America, after 2 weeks, the Fed is just going to look at, they're not going to track on individual account like every customer deposit. They're just going to look at the total size of deposit made in Bank of America for the past 2 weeks. If the total deposit by all customers is $20 billion, then by law, the Bank of America should keep 20% as required reserve. They should not lend that money out, and that money must be deposited with the Fed. Okay, so that means if the required reserve ratio is high, is 20%, the Fed is saying that 20% of every customer deposit must not be loaned out. So the Fed is constraining the ability of banks to loan out funds. And if the banks cannot loan enough funds out of customers' deposit, that is going to curtail their ability to create what? To create more money in the economy, to create more deposits. So money supply is going to shrink. Okay. On the other hand, if the Fed lowers the required reserve ratio to 10%, the Fed is saying that, okay, for every customer deposit, now we require you keep only 10%. You can loan up to 90% of that. So anytime the Fed lowers the required reserve ratio, the Fed is making it easier for banks to loan funds to the public from customers' deposits. So that is going to tend to increase the size of deposit in the banking system and the size of the money supply. But there's a fundamental difference between using the required reserve ratio from the first two policy tools that I discussed earlier, which is the open market operation, buying or selling treasury bonds, and giving loans to financial institutions. When the Fed is using the required reserve ratio as a tool to control money supply or money in circulation in the economy, changing the reserve requirement ratio does not affect the monetary base. Remember that. It affects the money multiplier or the simple deposit multiplier. Because remember, the formula, if we write the formula correctly here, we know that change in deposit equals to initial deposit or the size of the whatever initial deposit times 1 over RR. So the key idea here is that RR affects, because 1 over RR, remember 1 over RR is what we call the simple deposit multiplier. You can call it the money multiplier, but we just always like to call it the simple deposit multiplier. So changing the required reserve ratio is going to affect the money multiplier, the simple deposit multiplier. If the Fed decreases RR because it's at the bottom, that means this ratio is going to go up. So a decrease in the required reserve ratio is going to increase the simple deposit multiplier, meaning that for any deposit made in a bank, that deposit is going to create more dollars. But when you increase the reserve requirement ratio, that means the simple deposit multiplier 1 over RR is going to go down because you're increasing the denominator of this 1 over RR. Okay. So that is going to reduce the ability of banks to create more dollars from customers' deposits. Okay. So again, I want to reiterate this. Changes in reserve requirement ratio by the Fed do not affect the monetary base. Neither do they affect the reserves in the banking system. Only it affects It affects the simple deposit multiplier. Okay, there are other new tools that the Fed have come up with, which I talked about, the last 3. So since 2008, for example, the Federal Reserve started to pay interest rates on bank reserves, okay, on both the required and excess reserves. Ever since the Federal Reserve was created in 1913 through an act of Congress, okay, until the summer of 2008, the Fed never paid interest rate on reserves. Remember, reserves are bank deposit with the Fed. It's just like you. When you deposit money into your bank account, be it a savings account or checking account, you should expect interest rate to accrue on your deposit. But for the Federal Reserve, banks deposit money with the Fed. The Federal Reserve never paid interest rate on those reserves until the summer of 2008, when Ben Bernanke was the chair of the Fed and his group changed that policy. So from the summer of 2008 up to today, the Fed started to pay what? Has paid interest rate on reserves. Okay. So the question is, how do changes in interest rate paid on reserves by the Fed affect money supply? So think about it carefully. Remember the money that the banks are keeping with the Fed. If that money is just sitting within the Federal Reserve facility, that money does not create more dollars in the economy. So the idea here is that if the Fed makes it enticing for banks to keep their money with the Fed, let's say they increase the interest rate on bank reserves, then banks all over America are going to say, well, it's safe to keep the money with the Fed. And since they're paying us already a high interest rate on our reserves with them, we're just going to continue earning interest rate on those reserves. We're not going to take those money out to lend to the non-bank public. So the money would just be sitting and piling up within the bank account with the Fed, the reserve account. That money never gets its way back to the public to create more dollars. So that is going to reduce the money in circulation, because banks are not going to be creating money because they're earning huge interest on their reserve account with the Fed. And so the idea is that increasing interest rate on reserves paid by the Fed to banks is going to reduce the the ability of banks to loan out funds, because banks are going to find it more attractive to just keep accumulating reserves with the Fed and earn higher interest rates instead of taking that money and lending it out to create more dollars in the economy. And the converse is true. If the Fed wants to increase the money supply in the economy, they will lower the interest rate on reserves. If they lower the interest rate on reserves to a very low level, then banks are going to say that if we keep the money with the Federal Reserve, we don't get paid enough interest. So we're just going to use that interest money again. We're going to take our money instead and loan it out to the non-bank public or loan it to other banks. We're going to make more money, by earning better interest rate. So lowering the interest rate on reserves, interest rate paid on reserves by the Fed is going to increase the money supply, and increasing the interest rate on those reserves tend to decrease the money supply, because it limits the ability of banks to lend out funds, because banks are going to be more enticed to keeping or accumulating their reserves with the Federal Reserve. Okay, so that is how that tool now the Fed can use that tool. Then there's another tool way of controlling money supply. We call it the overnight reverse repurchase agreement facility. So large banks, okay, and other financial firms often use repurchase agreement to borrow and lend with each other and with the Fed for very short periods, typically overnight. So when we say overnight reverse repurchase agreement, we also call it reverse repos. Another word for it, in short, we just call it, they say it here. We call it reverse repos. So this idea is that the Federal Reserve sometimes may want the effect of monetary policy or bond purchase to be short-lived in the economy. They don't want the impact on money supply to be long-lasting. So if they want the impact of that bond purchase to be temporary, they could enter an agreement with banks that they're going to buy bonds from banks, okay, or sell bonds to banks today with the agreement that they're going to repurchase it back in maybe in 2 weeks, typically in 2 weeks. Okay, so that's what we call repos. And then the last one is what we call a term deposit facility. So since April 2010, the Fed has offered banks opportunity to purchase term deposit, which are similar to the certificates of deposit that banks offer to households and firms. So banks can go and purchase like term deposit, where then the Fed pays them interest rate on it. So the interest rate over on term deposit is slightly higher than the reserve balances like bank reserves with the Fed. So when banks place money in term deposit, it reduces the funds available to loan. So that is going to reduce the money supply in general. So the idea is that if the Fed is offering higher interest rates on term deposit facility, banks are going to find it more attractive to invest in those, instead of lending money funds to the non-bank public and to corporations. So that tend to reduce the money supply, because banks are earning huge interest on their investment with the Federal Reserve instead of using that money to lend to the public. So an increase in the interest rates offered on term deposit facilities is going to reduce the money supply. But a decrease in that interest rate means that the banks might actually loan money to the non-bank public because they find that one to be more attractive instead of what? The low interest rate they would be otherwise earning from their term deposit facility. So those are how the tools of monetary policy work, how the Fed control monetary policy. I want to just mention a few, like one comment here. After the financial crisis, or slightly before the financial crisis of 2007, 2009, there has been an increase in what we call shadow banking. The banks we have been discussing so far are commercial banks. Commercial banks are banks that take out loans, that accept deposit from customers, and then they turn around and give out loans. So commercial banks include regular commercial banks, credit unions do the same, But over the last 25 to 30 years, there's been a rise in what we call shadow banking. Shadow banking, these are banks that don't engage in the traditional banking business. They do not accept customers' deposit. So a lot of those could include things like investment banks, like hedge funds and stuff like that. This could be mutual funds and stuff like that. So those banks have increased a lot over the past 25 to 30 years. Okay, so banks have begun to resell many of their loans rather than keep them until they're paid off. Financial firms other than commercial banks have become sources of credit to businesses. So we've seen that happening. So we call those shadow banking. And then the other thing that I want to talk about here, which also started in the 2000s, is maybe the concept of securitization. Securitization comes to banking. It's basically a new concept in that Wall Street invented like in the early 2000s, where it started in residential mortgages. Securitization is the idea that banks give out large mortgages and then they repackage those mortgages and create new financial products out of those mortgages and sell shares in those financial products. So the process of transforming loans or other financial assets into securities is what we call securitization. So like a bank like Bank of America can package so many mortgages they give to customers, and then out of that mortgages they're gonna package it and then start selling shares to willing investors who want to invest in those mortgage-backed securities. You probably heard about this concept a lot on Wall Street or on the news, the concept of securitization, mortgage-backed securities. I'm not going to waste a lot of time on that. So I talked about shadow banking, like several investment banks that don't perform the traditional role of banking, hedge funds, and the money market mutual funds. Those are a few examples of shadow banking. I'm not going to be talking a lot about the financial crisis. You can read that as your what happened in America in 2007 as you're free. You want to see the free time or during your free time, and what happened during COVID. Okay. The last thing I want to cover in this chapter that I want you guys to pay attention now that you know how the Fed controls the supply of dollars in the economy, we have also learned how we quantify the supply of dollars in the economy. Now we're going to start talking about how the supply of dollars in the economy can affect like prices in the economy, okay, or nominal GDP. Because think about it, if we print so much money, if the Federal Reserve prints so much money and dumps it in the economy, it has consequences for like inflation and stuff like that. So beginning in the 16th century, for example, Spain sent gold and silver from Mexico and Peru back to Europe. So there's a simple model we're going to be developing here is what we're going to be calling a quantity theory of money. So these metals that Spain sent from Mexico and Peru back to Europe were minted into coins, increasing the money supply in Spain. So price in Europe rose steadily during those years because of the increase in the money supply. So this helped people make the connection between amount of money that exists in the economy and the price level, the prices on goods and services. So I know before I took economics, when I was a young kid, I was like 9 years old. I used to walk with my dad in a poor neighborhood in my village, near my village. And I asked my dad, why is this neighborhood so poor? Why can the government print money and distribute the money from the sky, maybe drop $10,000 to each family so that they would be $10,000 richer? Then my dad told me that they would, in the end, they would be worse off. Then I asked my dad why. And my dad told me that I was too little to know that. Maybe that's the reason why I decided to choose to major in economics, so that I could learn why printing money and giving it to, say, American citizens would be disastrous for the economy. Okay, it would change prices in the economy. There's a common saying that the more money money digs down our pocket. If you print a lot of money and put it in circulation, it digs down your pocket. That when you have too much of it, that money is going to lose value. That losing value means that prices of goods are rising. So the available money cannot buy as much goods and services. So we can be worse off in the long run when inflation or prices are rising on us. We have seen the effect of that with COVID, because during COVID, the government pumped money in the economy to keep the economy strong, since we're in lockdown. And then when Americans came out of lockdown, they went wild with spending those COVID funds. What you see now, you look at what we are paying for today. Prices of goods are more than triple on us. Some goods are more than triple in it. You go to HEB, everything is so expensive. So that is the impact of printing too much money on the one hand and dumping it in the economy. So now we're going to learn the connection between the supply of dollars, the stock of money that exists in the economy, and the price level and nominal GDP. So that is going to be summarized into this quantity theory of money. This quantity theory of money was developed by some economists called Fisher from MIT back in the day. So let's look at how the quantity theory died. So let's develop this simple model. So you look at this. So there's a relationship, the quantity equation. I'm going to define those whatever. So let me first define those variables so you know what it's talking about. What we're talking about there. So there's going to be new variables that I'm going to define here. Okay, so I'm going to define M. M is going to be the stock of money or quantity of what money supply. Like M1, that's the supply of dollars in the economy, or stock of money that exists in the economy. And then I'm going to define some variable called V. V stands for velocity of money. So velocity of money, this is the average number of times that each dollar bill changes hands. Each dollar bill changes hands, or the rate at which money is circulating the economy. So the idea here is that if I went to my bank, let's say on January 1, 2023, and my bank issued me a brand new dollar bill, I'm going to use that dollar bill maybe to go to a convenience store and buy a pack of gum with it. And then that the owner of that convenience store might pay wages for their employees with that $1 bill that I gave them. And then the employee is going to use that. They're going to go to Walmart and spend that dollar bill in Walmart. So when you think about that dollar bill is going to change hands, it's going to travel quite a bit, because people are changing. So the number of times that a dollar bill is going to change hands, say in a year or in a month, is what we call the velocity of money. If each dollar bill changes hands on average, like say 10 times, then we say the velocity of money is 10. A dollar bill has changed hands 10 times. So that has got some implication with the money supply. Then the other variable that I'm going to define are going to be what you already know from our previous chapters. So let me open this new slide. So then the other variable is what we call, Y is going to be what we're calling real GDP. Or output, the amount of output that the economy is producing in any given year. And then we're going to P is what you already seen here. That's a price level, the general price level in the economy. And we know our price level can be, we can use a consumer price index. We have done that already, how to measure the general price level in the economy. Sometimes we can use a GDP deflator. So you go back to your chapters 8. We did all that there when we talked about GDP. You go back to your exam 2. We tested that a lot there. So P is a price level. So Fisher came up with a connection. There's a connection with that. If you multiply the supply of dollars in the economy, okay, times the velocity that each dollar bill out of that supply changes hands, that is going to be equals to what? The what? Okay, and the one is one thing that I forgot to define here. Let me. If you multiply P times Y, that is what we call nominal GDP, because nominal GDP is GDP at current prices. So this is the P times Y would be the value of all final goods and services produced in the economy in any given year. That's what we call nominal GDP. Okay. If I multiply price times each unit of good produced in America, P times Y would give you the what? The value of all final goods produced in the United States, say in 2023. That's what we call nominal GDP. GDP at current prices. So Fisher argues that there's a connection between the amount of money that people use to buy those goods, velocity, and that nominal GDP. So the formula is that if you multiply M, which is a total stock of dollars in the economy, by the velocity or the rate at which each dollar bill is changing hands, that is going to be approximately equivalent to price times Y, which is nominal GDP. Let's think for a moment. Let's say America has got like $3 trillion money that is circulating in the economy, like M1. What do we use money for? For buying goods and services. So there are so many transactions that are happening in the economy. Someone is going to buy a TV, somebody's buying a car, someone's buying a phone. And anytime they buy a phone, they may use cash. They may spend money to buy that. So the money is going to be changing hands. So if we multiply that 3 trillion, let's say the average number of times that velocity is changing hands was like, say, let's just pretend that this is 1.5. So let's say 15. Okay. Let's just say that. Let's put some number which is reasonable to the U.S. economy. Let's put 8. Let's say that on average, a dollar bill changes hand 8 times in a year. Just be conservative. So the idea here is that if I multiply the average number of times that each dollar bill changes hands times the total stock of dollars that we have in the economy that people are using to buy goods and services, this is going to give me $24 trillion. According to this model, this M times V that we multiply, because V is 8, M is 3 trillion. That should be equivalent to the what? The value of final goods and services that that people are buying. So that's why. So this MV equals to PY is basically true by what? By definition. So that's why we call this equation the quantity equation. And you could rewrite it in a much different way. That quantity equation can be written. You can make velocity the subject to even understand it more. Let's do that. So if you say M times V equals to P times Y, then that means if I divide both sides by M, M here is going to cancel. So velocity would be equals to nominal GDP, which is P times Y, divided by the stock of money. So let's think about it because you know what the definition of velocity is what? The average number of times that each dollar bill is spent. So let's suppose that the value of final goods and services, what we call real GDP, is PY. Let's say it was $24 trillion. And then we are dividing the value of goods and services that we are producing in 2023 by the stock of dollars that people are using to buy those goods. Let's say $3 trillion was the stock of dollars. Okay, this is 24 trillion up here. So see, the dollar sign is going to cancel. Trillions are going to cancel. The 3 goes into 24 like what? 8 times. So that means velocity is going to be 8 times. That means each dollar bill is changing hands 8 times in the process of purchasing goods and services that we are producing in the economy. So that's the interpretation. Now let's put some assumptions to this model, because every time we develop a model as economists, we put some supplying something. So you see, I'll use another example here. Like, for example, in 2020, when we're in lockdown, people were not buying goods. When you're in lockdown, we're not buying enough goods, so you would expect velocity to be low because we were in lockdown due to COVID. So you can see that the GDP for the United States in nominal GDP, P times Y, was $18.4 trillion. But the total stock of dollars, M1, was $12.9 trillion. So if you divided 18.4 by 12.9 trillion, you get 1.4. So that means during COVID, each dollar bill change hands 1.4 times on average. And that is understandable. It's quite a small number because in 2020, we're in lockdown. We weren't like, purchasing a lot of stuff out there because the economy was locked down due to COVID. So we can always calculate velocity, but will we always get the same answer? The quantity theory of money asserts that subject to measurement error, the quantity of money, theory of money, and theory about the connection between money and price that assumes that velocity of money is constant. So the first thing we're going to assume here is that what if velocity is constant? What do we mean by velocity constant? The idea is that the average number of times a dollar bill changes hands is going to stay the same between periods. So when you assume that velocity is constant, it means that if the average number of times a dollar bill change hands in 2022 was 5 times, it's most likely going to remain 5 times in 2023. That's an assumption of constant velocity, what that means. So what does that mean? And then we also know that in classical model, because you just assume the classical model, because it's a classical theory. So velocity is constant, we can say V equals to V bar. V bar on V means this is constant. And then we're also going to assume that if the economy is producing at full potential, which we say YP, potential output, when the economy has reached its full potential value of output, changes in the money supply will not affect GDP. The only thing that affects output when you are producing at your full capacity, when all resources have been maxed out, is when you build capital, you change technology, you increase the number of workers in the economy. Those are the things that will increase this output in the long run. We say the economy has already reached its what? Long run equilibrium. We talked about that when you talk about aggregate demand, aggregate supply, when the long run aggregate supply curve is vertical, meaning that printing money will not affect GDP once the economy has exhausted all its productive capabilities. The only thing that can change that output over time is when the economy builds more capital, increase the number of workers in the economy or get some new technologies. But printing money will not. So if we assume that economy is at in full employment, that means, so what's the implication of that? Let me show you what is going to happen here. So if we're saying that mv equals to py, velocity constant. So according to the quantity theory, if the economy is producing at full employment, this number is not going to change simply because you're printing money. So that means that if we hold velocity constant, velocity is not changing and the economy is already producing at full employment. That means changing the money supply will have a direct effect on price level in the economy. And the model actually predicts a one-to-one relationship. So the quantity theory, I'm going to do this and do an example. The quantity theory predicts a one-to-one relationship between money supply, which is M, and price level, P. Meaning that, so what does that mean when you say it predicts a one-to-one relationship between money supply and price level? It means that if we hold velocity constant and GDP is at full employment, if you increase money supply, let's say the size of money supply in the economy was $20 trillion, and let's say the price level was 100. If you double the money supply from whatever 12 trillion to 24 trillion, the price level is also going to double. So let's first do a couple of examples, because that is just like an equation that I want you to remember. So I'm going to do a couple of examples here so that you see what we're talking about. And you're going to get these exam questions on the exam, on your exam for sure. So I would say that suppose M is like, say, $10 trillion. And nominal GDP, which is P, nominal GDP is PY, is like, say, $20 trillion. Then I could ask you, calculate velocity. So this is easy. So you just write the formula. You're gonna say mv equals to p times y. So we have been given the money supply is what is given as 10 trillion. Okay, substitute it there, 10 trillion. Multiply that by velocity must equal to, what is that? 20 trillion, because nominal GDP is 20 trillion. So if you divide both sides by 10 trillion dollars, you go that the dollar sign is going to cancel out, trillion can't cancel out. So you get what? 10 goes into 20, what? 2 times. So velocity would be what? 2. So that means on average, a dollar bill changes hands 2 times in a given period. Okay. So most of the time I'm going to give you the known values. You solve for the unknown. It's very simple. Sometimes I may not give you nominal GDP. I could give you just real GDP. So I could say, it depends on how it is. So I could say, let's do another example. Say, suppose V is, say, 2 trillion. Sorry, no, 2. Okay. And then let's say P price is, let's say, price is 2 and Y is 10. Then I say, calculate M. So all you got to do, just remember the formula. The formula says that M times V equals to P times Y. Okay. So I'm going to substitute the known values. So that means M, which I'm supposed to be solving for, times 2 equals to P is what? 2 times Y is 10. So let's say this was 10 trillion. So you get what? You're going to get M, 2 times M equals to 20 trillion. So if I divide both sides by 2, divide by 2, you can see that your M is going to be 10 trillion. So it is very easy. So now the one thing that I want to show you though, I want to show you guys, they talked about how if we hold money constant, this one-to-one relationship I'm talking about. So that if you double them, because if we assume that velocity is constant and GDP's rate at full employment, meaning that increasing money supply will not affect GDP. Then what that means, so if you know already that MV equals to PY. So let's say, let's start with an initial value. Let's say V was 5. And that V is going to remain 5 every period because V is constant. That's the assumption we make. And let's say M was 10 trillion to begin with, 10 trillion. And then let's say the price level was 2. And then output here would be, we want it to balance was 2 times 25. So you can see clearly the left-hand side, 10 trillion times 5 trillion. This is in trillion. Okay. So I mean, price level is this is dollars. So this is going to be in trillion, 25 trillion. So 2 times 25, that's 50 trillion, must equals to 10 times 5. So the equation balances. So if I say, suppose if V is constant, meaning that V is going to remain 5 forever, and out of GDP, let's assume it's also at full employment. That means this is 25. That's not going to change. Suppose the Federal Reserve doubles the money supply. Suppose M is increased to, like, say, now doubling means we're going from 10 to what? To 20 trillion. If the Fed prints the money that money, so what would happen to price? As I said, the quantity theory predicts a one-to-one relationship between money supply and price level when you hold velocity and GDP constant. Meaning that if the Fed doubles the money supply, price level is going to double. And you can see that, and we can prove that. So if the money supply is now $20 trillion, we are multiplying 20 trillion by velocity. Velocity remains at 5. We want to see how price is going to change. Remember, GDP is constant. We have full employment. This is 25. So you can see, if I divide both sides of this equation by 25, okay, 5 goes there, 1, 5 goes there, 5. 5 goes there, 1, 5 goes there, 4. So that means the price level is going to be equals to what? To 4. So that means, see, the price level also doubles. That's what I mean by one-to-one relationship. So according to the quantity equation, once you hold velocity constant and GDP constant, Doubling the money supply leads to doubling the price level. If you triple the money supply, you let the money supply increases by threefold, price level is going to increase threefold. If you let the money supply increase 10 times as much, price level increases 10 times. If you decrease the money supply by twice as much, price level is going to decrease by twice as much. So it goes in opposite direction as well. If you decrease the money supply by 10 times as much, price level is going to decrease 10 times as much. So that one-to-one relationship is what we are talking about here, that a change in the money supply is going to trigger an equal proportional change in the price level when we are holding what? Velocity and GDP constant. Okay. So it looks like we are on a good whatever to completing this chapter 14. So the last thing I want to talk about now that we know, okay, so in economics, when you, or in mathematics, if you write something like this, if you write equation like this, I want to make sure, let me get rid of this. If you write equation like such as m times v equals to p times y, we call this level equation. Level equation. Like this m would stand for the level of money supply. That's why we call it level equation. Level of money supply. This v would be the level of velocity. So then levels, level of velocity. At that point in time, P is the, you and all you say, we call it the price level, level of price. And then this is a level of GDP, level of real GDP. So that is what we call level equation. But it's like saying, if you went to the mall yesterday and you found that the price on a dress was $100 yesterday, well, that's a price level. And let's say somebody goes back to the mall today and find that the price on the same dress that was $100 yesterday is now $110. So the price of the dress has increased. So it is also important now to know how the price of the dress is growing over time, what we call the percentage change. Okay. So we can, so when we, as much as we're talking about the level of money supply, we could be 10 trillion yesterday, then today means this year, it could be go to $15 trillion. Then we say that the money supply is growing. Okay. Price level is growing. Okay. So now we can say, I want to show you, you guys know how to calculate percentage changes. So we can express that. There's a rule of mathematics that I'm going to show you for expressing that. We call it the percentage growth rule. So you could think about the value, the level of money supply today. T stands for today. And the level of money supply, like say, one period yesterday. T minus 1 means 1 year from today, or 1 period from today. 1 period what? Ago. So an interesting question could be, if the level of money supply yesterday could be last year, and today could be this year, T stands for today, then how much would the money supply be growing? How do you take the growth rate? So you know that the growth rate, or the growth rate, is the same thing as percentage change. Okay. If somebody asks you to calculate the growth rate, the percentage change in the money supply, you know how to calculate, you take the money, this level of money supply today, you subtract from it its value yesterday, and then you divide it by its value yesterday. That's how you get the growth rate. Then you multiply this by 100, which is going to be the same. You can call this the percentage, in short, percentage change in money supply. In short, that's how you get the percentage change. And then you can do the same thing for all the other variables like V, T, V, Y, and P. So now there's a rule. I want to share with you guys what the rule of percentage change is, the mathematical rule. Okay, so I'm just going to show you guys one, because that's the one we are looking at. There are two rules of what? Of growth. So the rules of percentage change. Percentage change says that the first one is which we're going to be using this slide for this, or to convert that, is what we're going to call the product rule. The product rule says that if you want to get the growth rate of a product of two variables, like the growth rate in some product X times Y, that is approximately the same thing as the growth rate is equals to growth rate in X plus the growth rate in Y. You separate them by addition. That's a rule of growth. The second rule, which we're not going to use today, but it also is important for you to know, is what we call the quotient rule of percentage change, or the quotient rule of growth. Quotient rule of growth rate. So the second rule is what we call the quotient rule of growth rates. Sorry, quotient rule. So the quotient rule says that if you want to get the growth rate, or the growth rate means percentage change. So the growth rate in a quotient like X divided by Y, right? That's what I mean by quotient. That's the same thing as growth rate in X. Is approximately equals to growth rate in X minus the growth rate in the denominator, growth rate in Y. Okay? So what we're going to do, we're going to apply these percentage rules of growth to convert our level quantity equation into growth rate. That's what we want to do. Okay, so remember already, we have said, that we know that M times V, this is a level equation, must equal to P times Y. So if we take the growth rate of both sides, you know, an equation, what you have done on the left, you must do on the right. You know that. That's a simple algebra for you, simple arithmetic. So take the growth rate or percentage change. Growth rate is same thing as percentage change of both sides of the above expression. Then that means you're saying growth rate in M times V must equal to growth rate in what? In P times Y. And then now, because M in the left-hand side and right-hand side, those are product of two things. And the rule of growth is that when you're multiplying two variables, you can separate them by addition. So now we can apply the rule of growth, which is the product rule of growth. Let me open a new slides here. Apparently, slides they're kind of small. My handwriting are big, so they get finished quickly. But anyway, so we want to find out what we know. We're applying that. We know that the growth rate in, let me repeat that here, MV, okay, must equal to the growth rate in P times Y from the previous slide. So using the product rule of growth, that means the left-hand side can be written as the growth rate in M plus growth rate in V must equal to growth rate in P plus growth rate in what? In Y. So this is something very cool. Now, because we assume that since velocity is constant, that's why we talked about that. The growth rate of something that is a constant is zero. If something doesn't change, that means it doesn't grow. So because we assume that velocity was constant, we're going to assume that the growth rate in velocity is going to be zero. The economy is always going to grow, even though but we're assuming that is at full employment. Over time, when you build more capital, you build more technology, you increase number of workers, the economy is going to grow. So the long run growth could be there for the economy over time, you know, as long as you get new technology. And the growth rate in M, you can write the growth rate in M as delta M over M. That's another way of writing it. Then must equal to, sorry, because now this is zero, so it's going to be plus zero. Let me add that there, zero. Must equal the growth rate in the price level is what delta P over P, you can write it like that, plus the growth rate in GDP, which is, you can write this as delta Y over Y. Okay. And we know that the growth rate in the price level, the percentage change in the price level is what we call what? Inflation. You guys know this. Okay. So let me open another slide and kind of like digress that. We know that delta P over P, which is a growth rate in price, is what we call inflation. Inflation is a percentage change in the what? Increase in the price level. If that percentage change is negative, we call it deflation. So that means from this equation now, then we can say the growth rate in money supply, which is written as delta M over M, must equal to, I want to duplicate here first, delta P over P plus delta Y over Y, which I can now say delta M over M, delta P over P is what we're calling inflation, plus delta Y over Y, which is, so if I make inflation the subject of this formula, meaning I subtract growth rate in Y from both sides, growth rate in the economy. So that means inflation is going to be equals to the growth rate in the money supply minus the growth rate in real GDP. Okay? That is a very important formula that you need to remember, and you're going to love this. Okay? We call it, that's a model for predicting inflation that we have just derived. We have just developed a model for the, so this model is saying that the level of inflation in the economy is equal to delta growth rate in the money supply minus the growth rate in real GDP, the rate at which the economy is growing. Which with this guy here, or you can write it just in full and just say inflation equals to growth rate or percentage change in money, in money supply in M, minus growth rate in real GDP, growth rate in Y. This is a very important formula. You know, it's the same thing he's writing in a different way. Okay, so let's stare at this equation and discuss it. So this equation is saying that for countries that allow their central bank, like say the United States, if the Federal Reserve allows the money supply, the US dollars, to grow at a much faster rate than the rate at which the economy is growing. The rate at which the economy is growing is measured by the rate at which real GDP is growing. Let's say the economy, let's just put a number there. If the Fed allows the money supply to grow at 5% every year, but the economy is growing on average at 2%, then that means the economy is going to end up with inflation. Prices in the economy is going to rise up 3%. 5 minus 2 is 3%. So that's a very important whatever. It's a model that we can use to predict inflation in the economy based on what the Federal Reserve is doing. So that means there's a fundamental relationship between the amount of money that the government prints and the rate of inflation that exists in the economy. Okay, so let me say that again. That's saying that inflation equals to delta M over M minus delta Y, delta Y over Y. So again, let's go, okay, suppose, so if you want inflation to be zero, for inflation price not to rise at all in the economy, let's say the price level, general price level in the economy last year to be equal this year, it requires that the rate at which the money supply is growing between last year and this year must equal the rate at which the economy was growing between last year and this year. So let's say that between last year and this year, if the economy grew by 2%, and the Federal Reserve allows the money supply to grow by 2%, then that means inflation is going to be what? Be zero. This is a very important model that we use for predicting inflation. I want it to kind of sink in. So I basically discuss. And then, so what does that mean? Deflation means what? When you get negative number, that means deflation. So deflation is negative inflation. Means prices, general price level is falling. So where would you get deflation? So deflation is like when you allow the economy to grow at a much faster rate, like say 5%, and the Fed allows the money supply to grow at a much slower rate, only 2%. 2 minus 5, you're going to get negative 3%. That is what we call deflation, when you get a negative, when you allow the economy to grow faster than the rate at which the money supply is growing. So I discussed them here. All right. So we're just left with a few things. So we see the relationship in real terms. So when we look at, this is for the United States, when we look at the rate at which the United States has been printing money, you know what I mean? Going back to like even 1870s, 1920s, 1930s. Okay, we see that if you fit a line among these scatter plots of years, on the vertical axis, we're measuring inflation in America that have happened during all those periods. And the rate at which the money supply is growing is on the horizontal axis, M2 growth rate. You see that you fit a line, that line is most likely going to be upward sloping, meaning that periods like the 1970s, when the United States Central Bank allowed the money supply to grow at a much faster rate, that also corresponded to a period when inflation in America was very high. Okay. So again, and then I'm going to bring you, so I can bring, yeah, so make sure that also this is a formula that you're going to remember. Sometimes I may give you, I might give you inflation already, and then I give you the rate at which the economy is growing, delta Y or Y. Then you can solve for how much money supply should be growing. Or sometimes I may give you, say, suppose the money supply grows at 2% and inflation is 5%. What's the growth rate in the economy? So I give you two of the three unknowns. You should be able to solve for the what? For the last unknown value. And we look at a cross-section of countries. We fit a line in this cross-section of countries. We see that line is upward sloping. That countries that let the money supply grow faster, they also end up with inflation. Look at a country in this country, Angola, in Africa. It allowed the money supply to grow at 40%. And they ended up for nearly 30% inflation. Countries like Belarus, Eastern Europe, allowed the money supply to grow at what? Nearly 40%, nearly about 35%. But Belarus also ended up with very high inflation. The Democratic Republic of the Congo, see, allowed the money supply to grow at a very high rate. And even but the countries like the United States, the US is here. We don't typically allow money supply to go faster in America. We have control over how much money we print and release. That's why inflation in America is typically low. So there's a positive correlation between the amount of money you print as a central bank and how much that's going to cause havoc on the economy in terms of what? Higher price and inflation. You see that already here with COVID. Okay. So there's also a concept of higher inflation. There's what we call hyperinflation. Hyperinflation is when price level is rising by in excess of 50% per month. We call that hyperinflation. The United States is a country, one of those few countries that has never suffered hyperinflation. We have never had a time in America where inflation is rising by 50% or more every month. It has happened in other countries, like in Zimbabwe in the 2000s. Prices were rising by more than 10,000% per year. You can imagine that. Okay, at that rate, a can of soda costing $1, let's say one Zimbabwean dollar, this year would cost over 100 next year, and over 10,000 the next year after. That's when you see the effect of inflation. So Zimbabwean inflation will reach 15 billion% by the peak of 2008. We have seen the similar problems in Venezuela lately. In Venezuela, prices have gone up. Inflation has become a big problem. Okay, inflation rose to over 2 million% in Venezuela. Okay, so it becomes very expensive for an average person to buy goods and services. So hyperinflation tends to be associated with what? Slow growth and printing money. If not severe recession too. Examples of hyperinflation were in Germany, because Germany was forced to pay reparations when they did havoc during World War I. And German government sold bonds to its central bank, the Reichsbank, which was called the Reichsbank at that time, but eventually they transformed into the German Bundesbank. So when the government sold bonds, they said, when the central bank was buying bonds, that buying bonds means increasing the money supply. So inflation in Germany became uncontrollable in the 1920s. After World War I ended in 1918, in 1920s, the repercussion when Germany was forced to pay reparations, Germany suffered inflation because they didn't have money, so they were forced to print money. to the extent this how from 1920 to 1923, the German price index rose by 1,440 to 126. I can't even, that's like in trillions, 1,026 trillion, making the German Deutschmark, worthless. So the German money was called the German Deutschmark at that time. Okay. So that's the end of this chapter. Okay. So it looks like this recording is going to be super long. So what I'm going to do, I'm going to break them up into 2 segments because I want to take a break, and I'm going to do chapter 15, which is the last chapter, which is an extension of chapter 14. So I'm going to upload 2 videos, 2 links to 2 videos. You got to watch both of them. So what I've just concluded is what we were supposed to complete on chapter 14, which we never got time to complete. So make sure you watch this video, and then in the next one, I'm going to take a break and then do another recording for chapter 15. Thank you very much for now. I'll be right back.